about trying to understand a little bit better. Vertica does better here than DBMSs because it's column-oriented and query only accesses 2 columns. All right, so we have a number of additional database tasks in the paper. Selection, we call them the selection and join tasks. Hadoop also performs relatively poorly on those tasks. The reason for this is that the Hadoop join code gets a little bit hairy. It's one reason. The joins involve multiple rounds of MapReduce. It's not very straightforward to write joins, actually, in Hadoop. Vertica also does very well on some tasks due to column orientation, again, and its aggressive compression. All right, so now I want to talk about a task that's a little bit more suited, we thought, to the MapReduce framework. The idea is this is a computation that's meant to model something that's sort of like PageRank. I know this is not PageRank, but it's supposed to be a sort of a very simple thing that you can quickly understand. The idea is in every document, in this documents table, you find all the URLs embedded in that document, and then for each URL that you find, you count the number of references to that URL across all of the documents, okay? So in SQL, this looks like basically a UDF to extract all the URLs, followed by an aggregation. So we first create a temporary table that runs this UDF get URLs on the contents of the data from the documents table, and then from the temporary table, we just run one of these group by queries on top of it. As it turned out, this was surprisingly tricky to get to work in either of the database systems that we used. Vertica doesn't support UDFs, so we needed to write an external program to populate this temporary table. DBMSs had a buggy implementation of blobs, as I understand it, these text blobs, which meant that rather than storing the blobs in the database system, we actually stored references to the files in the database system, the names of the files, and then we read the names of those files out. It read those files in the UDF in order to do the processing. Doing this in Hadoop was really very straightforward. It was a comparative pleasure to use. Just to quickly show you the performance results from this, I don't have a lot of time to drill into the details. The paper breaks down the performance and why it looks like this in a little bit more detail. You see that Hadoop does slightly worse than Vertica and slightly better than DBMSs. So the sort of surprising thing about this is Hadoop doesn't really excel here either, even though this was a task that really relies heavily on UDFs. It has no benefit from indexing. It's not the kind of thing that you would expect the database systems to do particularly well at. All right, so just a little bit of discussion. So Hadoop, over all these benchmarks, Hadoop was much easier to get up and running. And the load times are substantially better. I mean, in effect, Hadoop, the loading is sort of non-existent. I mean, if your data is already in the file system, you wouldn't have any load time at all. The only load time is just to copy the data into the file system, in most cases. Hadoop query times, however, are a lot slower. So 1 to 2 orders of magnitude. Some of the queries in the paper actually show that Hadoop doing worse than the queries that I've shown you here. And the reasons for this are, again, not super surprising. Its lack of parsing, as I've already explained. It doesn't have indices. Its compression doesn't seem to work very well, and this sort of execution model where intermediate results get written to disk. All right, so now that I've said that, I want to take a step back and do this navel gazing exercise. I've chosen a nicer navel here to show than mine. So when should we use MapReduce? Well, MapReduce, if you think about it, is really designed. I mean, what it's good at are these kinds of one-off processing tasks, where you're building the Google index. You sucked in all the documents that are out there in the world, and then you want to build the index on it. You're never going to go back and look at the documents again. It's great in that kind of a setting. Fast load times are important. You don't need any repeated access to the data. And that's, in those settings, maybe lack of a schema isn't such a big deal, although maybe having lack of a schema makes maintaining the Google indexing code kind of a pain. The fact that there's no indexing doesn't really matter because you wouldn't benefit from an index until you loaded the data. It's not so bad. However, I want to say that there's no compelling reason in our experience to choose MapReduce over a database for a traditional database workload. Okay, so what you're doing is online analytics processing, repeatedly rescanning the same data over and over again. But we don't see any evidence from this benchmark that it makes any sense to choose MapReduce. For example, one claim that you often see about MapReduce is that MapReduce is more scalable than database systems in some way. We don't see any evidence to support that in the benchmarks that we have. Okay, so what would Mike Stonebreaker say? Well, Mike Stonebreaker likes to say that MapReduce is just an ETL tool. And if you're a data warehousing guy, that's sort of probably the right perspective, right? You look at this in the right way and you say, this is something that might be usable for loading data into my database system. But it's not, it doesn't seem to make a lot of sense to use it as a competitor to a database system. So just to wrap up and conclude, MapReduce and database systems in a sense fill different niches, one-off processing versus this kind of in MapReduce versus repeated read access in database systems. There's lots of things that are really great about MapReduce. It's easy to use, has a good out-of-box experience. has this nice sort of only single programming language, has some attractive fault tolerance properties, has very fast load times if you want to get up and running on a, quickly process a data set, it might be a good choice. Databases, as we all know, fast query times, indexing and compression, all the work that we've done on database query optimization over all the years, that pays off and it works. You get good performance. That's great. I do want to acknowledge that there have been lots of recently proposed hybrids of database systems and MapReduce in various ways. These are systems like Hive, Pig, Scope, Dryad, Link, Hadoop, DB, so on and so forth. Okay? These are all basically things that either try and layer database-style processing on top of MapReduce or try and sort of hybridize these things in other ways. It would be very interesting to see how these systems compare performance-wise on this kind of benchmark to a system like to the systems that we compared to in this talk. It also would be, I'm very interested to see how much you give up by layering things on top of MapReduce. How much does this MapReduce execution model fundamentally limit the performance that you could get out of building something, say, like Hive on top of MapReduce? Okay, so I want to let Mike have one last word here. Mike loved this expression, it's time for a group growth. Okay, and I'll just leave you guys to think about exactly what that means. But I just want to finish up with one sort of call to arms, which is, you might be wondering why is it Hadoop gets used so much. I don't think the answer is, why do people like Hadoop if the performance isn't that good? Why would people build a distributed database system, something that looks a lot like an OLAP engine on top of Hadoop? And the answer is because Hadoop, one, it works. It's open source. There's lots of people maintaining it, and it's very easy to get lots of parallelism out of it. Okay, so there's no, as far as I know, there's no reasonable open source, well community supported shared nothing parallel database system, and we really risk, people just saying, the way that I'm going to do my parallel analytics is using Hadoop, rather than them going and using database products. And I think that's something that we all should think about a little bit and be a little bit worried about. So with that, I'll wrap up. Thanks very much.
So based on what you say and on the evidence from the benchmark, you think it's a straightforward sort of generalization to say that the database code would scale up to 1,000 or 10,000 machines? And if not, how does this play into your argument?
So, what I said was, I don't see any evidence based on the benchmarks we've run that there's a scalability problem with database systems. I think that no matter any time you want to take a system and make it scale from 100 to 1,000 nodes, there's going to be a lot of engineering to be done. Okay, that doesn't mean that I don't see any. There's no evidence to me that there's anything about the MapReduce framework that makes it fundamentally more scalable than distributed shared nothing databases. There's exactly what's that?
It does work on 10,000 nodes, though.
I haven't seen any benchmarks showing Hadoop working on 10,000 nodes. And it's true that database vendors don't seem to feel that there's a lot of urgency to support or to run things on 10,000 nodes. But to me, that's not evidence that there's a lack of scalability in database systems.
Okay, we have some more time.
Hadoop does run on tens of thousands of nodes.
Okay, great.
I do agree with your comment.
Okay, I don't. That's fine. Yeah.
No, but that notwithstanding, I do agree with your comment that I don't see a fundamental issue of scalability.
I think that's.
On the other hand, there's one point I'd like to bring out here. The reason that people are using Hadoop, I think, beyond the availability, it's a programming model. It really makes it easy to write a whole class of programs and have them be parallelized. Okay? And that productivity is something that's attractive.
I agree with that. I think people find
an issue. I wish more people would work on it.
I think people find Hadoop to be very natural to use. I also think, though, that if there were a parallel open source database system, people would use it. People are hungering for systems that do this. So, Joe?
So, I think, the setup for the conversation is so all wrong that it's really scary. The idea that there's Hadoop and that's them, and there's something which is a full function ACID compliant SQL engine, and that's us, it's just idiotic. It's the wrong conversation to have. MapReduce is a programming interface, we can support it, that's fine. Hadoop has a feature which is that it can, mappers can fail it, you can restart them, that's fine. What we should be doing is taking these people who are excited about big data and embrace them. Hadoop is an on-ramp to things that we can add value to. And as an intellectual community, what we need to do is not go to them and say, your tool sucks. R2 is so much better, really, except it doesn't do what we want.